Good morning, sir. I am Dinesh Kumar from third year mechanical. Today I am going to present a topic on taper turning. At first, introduction to the taper turning. Taper turning is a machining process used to produce a gradual decrease or increase in the diameter of the workpiece. It is commonly performed on the lathe machines to create conical or tapered surfaces. The process is essential in manufacturing components like shafts, cones, or fittings that require precise taper angles. Importance of the taper turning. Taper turning allows for the production of parts with specific geometric requirements. It enhances the fit and function of assembled components. Accurate taper turning improves the overall quality and performance of mechanical parts. On types of tapers in the turning. The most common types include straight, steep, and compound tapers. Straight tapers have a consistent angle along their length. Compound tapers involves two different angles along the workpiece's length for complex geometries. These are the different types of tapers in turning. The first one is facing and taper turning and contour turning and form turning and chamfering, parting off and threading and soaring, drilling and knurling. Methods of taper turning. The most typical methods involves using a taper attachment on the lathe. Alternatively, the workpiece can be set at an angle on the carriage for the taper turning. Digital or CNC lathes can perform taper turning automatically with programmed angles. Taper turning tools and attachments. Special taper turning tools are designed to cut tapered surfaces efficiently. A taper attachment is a device mounted on the lathe to guide the tool at a specific angle. Form tools and fixtures can also be used for precise and repetitive taper turning operations. Calculating taper turning angles. The taper angle can be calculated using the difference in diameters and the length of the taper. The formula involves the attachment of the difference in the radii divided by the length. Accurate calculations are vital to achieve the desired taper and fit in the assembly. Here the taper angle calculation formula: tan alpha equals to d1 minus d2 by 2l, where d indicates the larger diameter of the taper in mm and small d indicates smaller diameter of the tapered in mm. L stands for length of tapered part in mm. 2 alpha full taper angle and alpha is the angle of taper or half taper angle. Taper turning process steps. Secure the workpiece firmly in the lathe chuck or fixture. Set the required taper angle using the taper attachment or by adjusting the workpiece angle. Proceed with cutting the taper gradually, ensuring smooth and consistent surface finish. Common challenges and troubleshooting. Inconsistent taper angles can result from the improper setup or tool deflection. Excessive tool wear may affect the accuracy of the taper surface. Ensuring proper alignment and using sharp tools can mitigate common problems. Applications of taper turning. Taper turning is used in the manufacturing machine tool components such as spindles and cones. It is essential in producing tapered fittings for piping and plumbing. The process is also vital in making automotive and aerospace parts requiring precise angles. Conclusion and summary. Taper turning is a fundamental machining process for producing conical surfaces with precision. The choice of methods depends on the required accuracy, complexity, and production volume. Mastery of taper turning techniques ensures high quality components and efficient manufacturing. These are the taper turning methods: farm tool method, tailstock set over, and compound rest method, and feed combining method. Thank you.